The one thing you can say about ethics for engineering is that it's really, really difficult. You work with mathematical models, you build machines, you test the machines, you try and verify them as best you can. But when it comes to ethics, there are really, really difficult issues because there's no right answers. We have to think about all the sort of issues that could arise from the artifacts we make. But let's take the autonomous car. Now, one of the reasons why it's very difficult to legalise the autonomous car at the moment, or even to get insurance for it, is because it's difficult to work out who's responsible for accidents, who's accountable. I lined it up nicely, I set the parking programme in operation, it goes backwards and it runs over a child who gets in the way. Did I not clean the sensors properly? Is it the responsibility of a big truck that drove past just as I was parking and splashed mud in the sensors? Is it faulty software? We all know what happened with cars software recently. Who took responsibility? Is it the device itself? Is it something to do with the manufacture of the sensors? Is there a flaw that people didn't recognise? So these are all very, very hard ethical issues. You're all used to having this idea of professional code of ethics. So you're a good engineer, you look after your client. But we're talking about a different kind of ethics. We're talking about the ethics of social responsibility. It's societal ethics. So it's your responsibility to your society and to humankind. Now, there are plenty of people who will argue that ethics has to be really objective. But, if you look at utilitarian ethics, you're looking at things like, how does this add to our happiness? So you need to be thinking in an emotional way quite often, because ethics is quite often done on the fly. You need to have compassion for other people. Look, I'm not trying to be the high priest of ethics here. I work in robot ethics in particular and the ethics of emerging technologies. This is very difficult territory and I can't tell you how to progress really because it's up to you. When you're building an artifact, it's very, very important that you don't oversell it and be very, very truthful about the limitations. I mean, if we look at GM crops, for example, as a sort of analogy, you can do this in the laboratory, you can do it very well in the laboratory, but then you take the crops out into the real world and they start breeding with other crops, so they're in the wild. Think about what your device will do in the wild. It came up when I was talking to a group of military officers at the academy in Estonia who were going for accelerated promotion. And we were talking about the use of autonomous cars as a supply line, because they said, well, you've got these cars driving in a big supply line, but what if children get in the way? And most of them said, oh my goodness, yes, we couldn't really have this kind of supply line. But one of them said, well, one or two children's worth the sacrifice. So you really have to think about this. Now, of course, one of the big problems here is that everybody will know if you've got your very, very strong ethical governor on, if you've got your headmistress standing over you with a cane as your superego, how creative are you going to be? You naughty, naughty man, you naughty woman, how dare you do this? That's not going to help you, that's going to constrain you a lot. So in some way you have to negotiate a path through your ethics. You have to think, well, maybe not switch it off, because if you switch it off, you run the danger of creating a beautiful monster that you then can't bear to destroy. I mean, think about creativity. If people had been really, really worried, we wouldn't have had the atomic bomb.